All right, chapter 4 starts getting into taking what we learned in chapter 3, which was basically getting into the types of gates we have out there and building some truth tables and actually creating some circuits. So what we're going to do here is actually talk about, we're going to get into creating circuits using Boolean expressions. So we're going to take, and we could either have the logic circuit itself, or we could actually have the truth table. So we're going to start out with some basic foundations on this chapter. So first thing we want to do is talk about the sum of the products. Sum of the products are what I call SOPs. If you look at the sum of the products, that is, if you look at this part right here, the sum of the products, this is A and B ORed with B and C. So we have and an OR logic in here. And what we could call these parts right here, the A and B and the B and C, we can actually call them our midterm forms. These are the and terms. Likewise, the products of the sums, or the POS as I call them, is if you look at D or E and F. So these are the max terms. These would be max terms. These would be the max terms, we call them max terms. So if they're OR together, we call them max terms. And if they're AND together, then we call them the midterms. So just FYI to you on that, please read that section real closely and you should get some basic, a little bit more clear foundation behind it. If you have any questions, outreach to me on it. So if we're going to look at a max term, let's say we're going to do a max term. Remember, a max term is the D or E and the E or F. And so in this case, what we have here is this equation, this Boolean equation right here. We have A or B or C ANDed with A naught or with B naught is equal to Y. So we're looking for what is the max term of this logic gate. So the max terms we're going to do is, first of all, we can identify the max terms here. That's this part right here, A or B or C, and then we also have the A naught or B naught. So what we want to do is we want to take max term and figure out what this gate is, what this equation, this Boolean equation is going to look like. Basically, what kind of gates are we going to have in it? Well, step number 1 on here is what we want to do for this is take and break this up. So the A or B or C is an OR gate, and it's a 3-input OR gate because we have 3 inputs right here. We also notice we have an AND here, so we're going to have some sort of AND gate. Well, that makes sense. And then we also have an A naught or B naught. So we have an OR gate, but we also have 2 NOT gates because these 2 are NOTs. Okay, so next step on this is the number of gates we need. Well, I just said that. That's 2 ORs, 1 AND, and 2 NOTs. So it would be 2 ORs, 1 AND, and 2 NOTs. I'm going to bring this down a little. There we go. So first of all, I'm going to take this one here and I'm going to set this one up. So this is the first OR gate I have. So at A or B or C, so I got 3 inputs here, A or B or C, and here's the OR gate. Here's the OR gate. And then we also have down here, is another OR gate. And then I also have the 2 NOT inputs here. So remember, this part right here has A or B, but it's also inverted, so it's not. There's the 2 NOT gates. So there's our B and C. And then finally, we have the AND gate. Well, these 2 OR gates are ANDed together, and we get an output. So what we're going to do is clean this up a little bit because we can do some connections. And actually what we do when we clean it up is we come up with this type of circuit here. So what we have here is I drew 3 lines out first. And then what I'm going to do is, you notice that my B's are going to be connected together. So you notice I use a dot right here. There's 2 dots right here. So here's my first OR gate. That's my 3-input OR gate. So that just feeds right in there. And then I take my B and C and bring it down to these 2 NOT gates. So it's NOT. And here's a NOT. And then I feed it into the OR gate. When I feed it into this OR gate and these 2 OR gates come together, here's my AND gate. And then here's my output is what? So basically we take in this max term right here, and we built a logic gate that is this. And we can continue to do that. And we're going to build these types of logic gates using Boolean expressions in the lab. So before we actually get into 4-3, how about if we do one more as an example? Just one more as an example. So I'm going to come up with something just on the fly here. So let's see if we can actually make this work. So I'm going to, let's say we have a max term equation, A or B, and let's say it's knotted. And then I'm going to have an and A, B, C naught, just like that. And this is going to be equal to y. First of all, we'll look what we have. Here's a max term, and here's a max term. Here is the whole equation for it. So this is an or. This is A or B naught. And this is A. There should be an or right there. Sorry about that. A or B or C naught is equal to y. So I'm going to write it out just like that. Again, A or B naught and A or B or C naught. So this is going to be a three input or gate. This is going to be an or. This is going to be a 2 input or right there. And here's my and. So if I look at this, I'm going to have, when I could just set out, I know I have three inputs, A, B, and C. So I can actually just write those out right here, A, B, and C. The thing is, I want to do is, I have these gates. So the first thing, before I actually get into building this guy up here, let's tackle that over here and see what these gates look like. So we have here, going this way, is my first OR. So that's going to be that OR gate. So I have two of them. A, but I have a NOT right here. So I have to have a NOT gate right here. So here's A and B. And B is going to be knotted, and then I'm going to have some sort of output. Now I have this guy right here. So I'm going to move that over there. I have A and B. So A and B again, but it looks like I have a C. It's going to be knotted. So here's my knot. I'm just going to draw that out. Now this is going to go to a 3-input OR gate. So if I look at this, there's that part. This AND is going to be someplace over here. So if I take and I say these are my power line, these are my logic lines here. So if I take this and I move this into the first OR gate right here, I don't need C, so I could just actually bring B over. So I'm going to do that. And here's my NOT. I'm just copying what I see down here. I'm going to bring that over. So this is going to be AB. And now what I have is a second one down here. So I'm going to just bring this guy down, just to bring him down. Here's an OR. Here's an OR. Here's an OR. So now this OR gate, I actually have a third input on this one, and this is actually knotted. Whoops, a little too far on that. Just like that. And then I'm going to bring down these A's and B's. So A, and then I'm going to bring down this B. This is A, B, and C. This is a C naught. This is going to be B naught, and this is going to be A. Now what I do is bring this over, and I bring this into a AND gate because they're ANDed together. Here it is. There's my output, right? Just like that. So the second part of this is actually getting into the truth tables, and this is where we're going to use the truth tables instead of having just the Boolean equation. We're going to use truth tables to actually develop our Boolean equations, and then from there we can actually build our circuits. So 4-3 actually gets into the truth tables.